Okay, cool. So yesterday we were discussing about this thing also, right? The modulus of a complex number. What does modulus mean? It is the distance from the origin, right? Obviously, modulus is always a positive number, right? Now, because it is distance. Okay.
Yes, sir.
Okay. Then we were discussing that modulus of a complex number and the modulus of its conjugate both should be same, right? X plus iy, x minus iy doesn't matter, right? Right.
Yes, sir.
We discussed this x plus iy into x minus iy should be equals to x square plus y square, right? That's what we are doing here, right? And whether you multiply and take modulus or take modulus and multiply, it's still the same, right? We were discussing this, we discussed this also, right? Then there is something called polar coordinates. Okay. So one way of representing this point is in terms of x-axis, y-axis, right? In terms of x-axis, this is x units from this y-axis and y units from x-axis. That is how we generally represent. This is called rectangular coordinate system. Okay. The other way to represent a point is it makes an angle theta with x-axis and the point is at a distance of r units from origin. Okay. This is sufficient, no?
Yes, sir.
If given distance and angle, obviously there is only one point, right? If you are given only angle, then it could be any point on this line, right? If you are given only angle. If you are given only distance, it could be any point on the circle, right? Circle of distance r radius r, right? No. If you are given only distance, then it could be a circle. If you are given only angle, it could be a straight line. But if you are given both angle and distance, that means it's a single point, which is basically the intersection of this circle and this straight line. Right now? Agreed. Clear as both of you? Hello?
Clear, sir.
Okay, very good. So now when we define angle, so there are various ways to define this angle. Either we call this as 36 degrees or 360 plus 30 or 720 plus 30 like this, right? Either pi by 6 or pi 2 pi plus pi by 6, whatever. Now, when we define angles, we agreed that the angles we define between minus pi and pi. Okay, this angle, whatever we are defining, this should be between minus pi and pi. So instead of saying it as 2 pi plus pi by 3, we'll just say pi by 3. Understood? Any angle we depict it between minus pi and pi. Understood? So if it was this angle, we would have called it 120 degrees or something. If this is the angle, right, then what would we call? We instead call out this angle. Understood? We would
Yes,
have
sir.
called this one as minus 135 instead of whatever, some 200 something. Okay? Understood, no?
Understood, sir.
Okay, very good. Now, obviously, the relation between this x and y in this r is obviously x equals to r cos theta, y equals to r sin theta, right? So that means we know how to convert from polar system to rectangular system, right? If you are given r and theta, what is the rectangular system? It is r cos theta plus I into r sin theta, right? Similarly, if you are given in rectangular system, you can convert it to polar system, right? How do you convert? X square plus y square equals to r and tan inverse y by x equals to theta, right? Agree, ma? This is
Yes,
how you will
sir.
convert, right? So the modulus and amplitude from uh, this theta should lie between minus pi and pi. Just remember this. This is important. So, for example, how do you convert this? What is the distance from origin? 1 square plus root 3 square, right? 1 square plus root 3 square, which is equal to 2. And what is the angle? The angle is tan inverse of this by this, right? Okay.
Sir,
So,
can you explain about that angle once again, sir?
okay, okay, okay. So this what is this one? This one is minus one minus root 3. This one is something like this, right?
Yes,
This
sir.
point is this. This point is this, right, Nama? Okay. Now you can call it. So what exactly is this point? This angle should be 60 degrees, no? Agreed?
Yes, sir.
Okay. So this y by x, what is y by x is actually 60 degrees. So this one by this one should be actually 60 degrees. But instead of calling 180 plus 60, what we actually do, we measure this angle, right? What is this angle? This should be minus 120, right? That's what
Yes,
he's
sir.
calling. He's calling it. He's calling it as minus 120 degrees. Okay. Agree,
Sir,
Amma?
like I want how to find cos theta and sin theta, sir.
Okay. So this one minus 1 means r cos theta, right? And minus root 3 means r sin theta, right? And what is r? Minus 1 square plus minus root 3 square. Agree, Amma?
Yes, sir.
Okay. So what exactly we are trying to do here is this is this point, right? This point
Yes,
is
sir.
minus 1 minus root 3, right? And r is the distance from the origin to this point. What exactly is that? This is actually 1 square plus root 3 square. That is 2, right?
Yes, sir.
And this one cos theta, right? This one cos theta is actually this one. This one, sorry, this one cos theta is actually this one. This one sin theta is actually this one. Understood?
Understood, sir.
Okay, that's what we are doing here. So obviously, cos theta equals to minus half and sin theta equals to minus root 3 by 2. He is saying this one is actually in third quadrant. That anyway we can easily decide that this is already in third quadrant, right? Okay, and if it is in third quadrant, what should be the angle? Either you will call it 240 degrees or minus 120 degrees, right?
Yes, sir.
Understood, no?
Understood, sir.
Okay. Now, the same cos theta plus I sin theta, we call it as cis theta, which is nothing but e power I theta. Understood? Cos theta plus sin theta, we call it as e power I theta. Okay, this is very important. Okay,
Yes. Yes, sir.
okay, this is very, very, very important. Okay, now just see this cos theta plus I sin theta into its conjugate. Cos theta minus I sin theta. This is equal to 1, right? If you multiply this, it is a square minus b square, which is nothing but cos square plus sin square theta, which is equal to 1, right? Now, what does it mean? Cos theta plus I sin theta equals to 1 by this thing. Cos theta minus I sin theta. This is what he is saying. Either cis theta, you can call it as cos theta plus I sin theta or 1 by cos theta minus I sin theta. Okay? Okay. And another
Okay,
thing,
sir.
sometimes you will encounter not just cos theta plus I sin theta. You might encounter something like this, sin theta plus I cos theta. Then you convert this in this format, right? Sin theta will write it as cos of pi by 2 minus theta. Cos theta will write it as sin of pi by 2 minus theta. Then this becomes cis of pi by 2 minus theta. Okay? If you are given like this, you cannot directly operate it with cis theta. Okay, cis theta we have a lot of easy operations. You will understand. You will understand now. Okay. Now, uh, okay. Just look at this. There's a complex number. Okay. Let's call this distance is 2 and this angle is 30 degrees. Okay, ma? Distance is 2 and angle is 30 degrees. R comma theta. Okay. R1 and theta 1. Agreed? And let's say there is some other complex number R2 whose length is actually 3 units and angle is actually 40 degrees. Okay, ma? When we do complex multiplication, what we get? We get the magnitudes get multiplied. That means if you multiply this Z1 and Z2, okay? If you multiply Z1 and Z2, we should get a Z3. What is that Z3? Z3's magnitude is R1, R2. Okay, that means 6. And Z3's angle is theta 1 plus theta 2. That is 70 degrees. Understood? So if you multiply these two, this is Z1 and this is Z2, right? Understood? Then you will get a third complex number whose magnitude is 2 times 3, 6. That means it should be very big. Okay? At the same time, what is this angle? This angle is this 30 plus that 40, total 70 degrees. Understood?
Understood, sir.
Understood. When you are multiplying two complex numbers, what will happen to their magnitudes? The magnitudes will get multiplied. What will happen to the angles? The angles will get added. Okay? This is very important.
Okay, sir.
Angles will get added, magnitudes will get multiplied. And what is he doing? He is exactly doing the same thing here. There is Z1. We are calling it as R1 and theta 1, which is nothing but R1 into cos theta 1 plus I sin theta 1. Right? And Z2 is calling as R2 and theta 2 and is multiplying Z1 and Z2. That means he is multiplying this and this. He is multiplying this and this, and he has got R1 into cos A cos B minus sin A sin B, which is cos A plus B. Similarly, R1 R2 into again sin A cos B plus cos A sin B sin theta 1 plus theta 2. That means ultimately what we have got R1 R2 into cos theta 1 plus theta 2 and sin theta 1 plus theta 2. That means R1 R2 is theta 1 plus theta 2. Right? You can do the small verification yourself. Agree, Emma? Basically,
Yes,
when
yes.
two complex numbers are multiplied, what will happen? Their magnitudes will get multiplied, their angles will get added. Okay? Now, if it is happening with two complex numbers, obviously it will happen with any n number of complex numbers, right? So, for example, if there is Z1, Z2, if you multiply, it becomes R1, R2 and theta 1 plus theta 2, right? If you multiply this one with some Z3, let's say R3 and theta 3, what will happen? This one will get R1, R2, R3 and the angle will become theta 1 plus theta 2 plus theta 3, right? Understood now?
Yes, sir.
Okay, so there are multiple complex numbers. What will happen? All the angles will get added and all the magnitudes will get multiplied. Okay, ma? This is clear now. Now,
Yes,
now
sir.
the reverse operation of this. The reverse operation of this. What is the reverse operation? If there is Z1. Okay, Z1. Let's say it was earlier we were doing 3 and 30 degrees. This is Z1 and Z2, let's say 4 and 40 degrees. And Z3, how much we decided? Z3 will become 12 and 70 degrees, right? Z1 into Z2 equals to Z3, right?
Yes, sir.
Z1, Z2 equals to Z3. Now, by the same logic, Z1 should be equal to Z3 by Z2, right? Agree? Or Z2 equals to Z3 by Z1, right?
Yes, sir.
Agreement. So now then what does that mean? If you are dividing a complex number with some other complex number, the magnitudes will get divided. So for example, we want to do Z3 by Z2, right? So that means what we will do? First we will do 12 by 4, which is equal to 3, right? And angles will subtract 30 minus 40, 70 minus 40, which is equal to 30. Now we are actually getting this Z1. Understood? We are doing the reverse operation of multiplication. If you are doing division, what will happen? The magnitudes will get divided and angles will get subtracted. Okay, ma? Clear now this one? Same exact opposite.
Yes, sir.
Okay, very good. Now, say for a little understanding, when we talk about I is this one, right? What does I mean? I means 0 plus 1 into I, right? What is the magnitude of I? Magnitude is 1. And what is the angle? It is actually 90 degrees. When we say 1 and 90 degrees, what exactly do we mean? We mean I, right now?
Yes, sir.
Okay. Now what you are doing, 1 and 90 degrees, will multiply with 1 and 90 degrees. What should happen? Magnitude should get multiplied, right? We'll get 1. Angle should get added. That means 180 degrees, right? And what exactly is this point? 180 degrees. That is this point, right? 1 unit. 180 degrees means that is this point, right now? Which is nothing but our
Yes, sir.
minus 1, right? Which is nothing but our minus 1, right? So that's how we got I square as minus 1. It is consistent with our definition, right?
Yes, sir.
Understood no? I square equals to minus 1, how we got?
Sir.
I square equals to minus 1. You understood how we got I square equals to minus 1, no? I into I, which is nothing but complex number into complex number, right? The magnitudes are getting multiplied and angles are getting added. Right, Nama?
Yes, sir.
Clear, no? Rishal,
Cl-
clear?
Clear, sir.
Okay, very good. Okay, so now that's what he's saying. When two complex numbers are multiplied, angles get added. Okay,
Okay, sir.
okay. Now, one thing you should take care is when you are multiplying complex numbers and when you are adding angles, right? So sometimes you might, when you add angles, the angle might come out to be 240 degrees, right? But you cannot call the angle as 240 degrees. Instead, you will call it as minus 120 degrees. Okay?
Okay, sir.
Agree, ma? Okay. So this one is pretty easy. This square plus this square is actually the radius, right? And in which quadrant is it? This is in which quadrant? This should be in
Second
second
quadrant.
quadrant. This should be in second quadrant. So tan theta equals to minus root 3, and it should be how much? 120 degrees. That's what he's saying. Okay, ma?
Yes, sir.
Okay. Now minus 1. This should be in third quadrant, right? And what is the magnitude? Magnitude is root 2 and it should be in third quadrant. That's why we are calling it minus 3 pi by 4. Understood?
Yes, sir.
Okay, very good. So, uh, okay, now fine. If the amplitude of this thing is pi by 2, okay, here what we'll do, we'll assume z as some x, right? X plus iy, okay, x plus iy minus 2 by x plus iy minus 6. This amplitude should be equals to 90 degrees, right? One second, ma. Hello? Agree, ma? We are calling z as x plus iy
Yes,
and
sir.
we are just
Yes, sir.
substituting here. Okay. And then we are simplifying this. What we are doing, we are just multiplying with this conjugate. Okay. We
Yes,
simplified,
sir. Yes.
we simplified, and we got a plus ib. This is this, this is this. Right? Okay. So now, if the angle is pi by 2 for this complex number, if the angle is pi by 2, what does that mean? This one should become 0, no? Agreed.
Yes, sir.
For this complex number, obviously the real part should become 0, no? If the angle has to be pi by 2, then this one
Sir,
should
can
become.
you explain that pi by 2 part again, sir?
Okay, okay. So this angle, so this is a complex number, right? Z minus 2 is a complex, Z minus 6i is a complex. Together it is together as a complex number, right?
Yes, sir.
Okay, and what is that complex number? That is this. Okay?
Okay, sir.
This one, let's say this is something of the form a plus ib, right? Now a plus ib, this angle is 90 degrees. What does that mean? A plus ib should be on y-axis, on the positive y-axis, right?
Yes, sir.
Agree, no? A plus ib is a point. And this point, it should be angle should be 90 degrees. What does that mean? This point should lie on y-axis. That means A should be 0. Right?
Yes, sir.
That's what he's saying. That means this should be 0. And if you simplify this, you are getting a circle. Okay?
Okay, sir.
Understood?
Yes,
And
sir.
and at the same time, this is a circle. At the same time, he is saying it is pi by 2. He is saying, and it should not be minus pi by 2. What does that mean? This point, this b should be greater than 0. Right? This b should be greater than 0. Otherwise, it could be this point also. Right? If a is 0, it could be this point also. Right? And that's why he is forcing this also to be greater than 0. That's why this is another condition. Right? Understood? Agree, ma?
Yes, sir.
Okay. So now this condition has given us this circle. This condition has given us this inequality in the form of straight line. So what he's saying, this is some circle like this, and there is some straight line, okay, and this region above the straight line, as well as the part of the circle which is in this. So he's saying actually this portion of the circle is this locus. Okay, ma? Understood?
Yes, sir.
Okay, next one. Show that the equation of circle in complex plane should be of this form. Okay. Now we know general equation of the circle is like this, right? X square plus y square plus 2gx plus 2fy plus c. Okay. And let's assume that there is a complex number x plus iy. Okay. Which is x plus iy. Right. Now, if z equals to x plus iy, z plus z complement by 2. That should be equal to x, right? X plus iy plus x minus iy by 2. This is what we are saying. This should be equal to x, right? Similarly, x plus iy minus of x minus iy by 2. That should be equal to this thing, right? By 2i. That should be equal to y. Agree or not? Is this part is clear?
Yes, sir.
Okay. So we have got y, we have got x, right? And what is x square plus y square? X square plus y square is obviously mod z whole square, right? And earlier we discussed mod z whole square is nothing but z into z complement, right? So what we are saying, x square plus y square, we are replacing z with z into z complement, and 2z into x we are replacing with this, and y we are replacing with this, and c is as is. Okay, we have done little bit algebraic manipulation, and we are and lot of things will get cancelled, and this is left. Understood? This part is clear, ma?
Sir, a little bit tough. Sir, can you explain the starting section once again, sir?
Okay. Got it. Wait. So there is this complex number x plus iy. Okay.
Yes, sir.
Okay. And the first of all, this is the general equation of circle. This you know, right?
Yes, sir.
This we want to express in terms of complex numbers. Okay. Let's say there is some complex number x plus iy. That means there is some point, right? Then what is
Yes,
z?
sir.
Z complement is x minus iy, right? That means z plus z complement is 2x, right? That means
Yes,
x
sir.
equals z plus z complement by 2, which is this. Okay.
Yes, sir.
Agreed. Now, z minus z complement is iy minus iy, which is 2iy, right? 2yi, right? Or 2iy, whatever. Okay, ma? Then what is
Yes,
y?
sir.
Y is z minus z complement by 2i, right?
Yes, sir.
Okay. Now we will multiply both numerator and denominator with I. Okay. So this becomes what? I into z minus z complement by 2i square, which is nothing but minus 2, which is this minus. Okay. Minus of I
Okay, sir.
into z minus z complement by 2, right? So we found out what is x, we found out what is y. Now we'll go and substitute that x and y in this equation. But before that, we know z into z complement is nothing but x square plus y square, right?
Yes, sir.
Agreed. So this x plus y square will substitute it as z into z complement, and 2z into in the place of x we'll put this, okay, and 2f into in the place of y we'll put this, and c as is, and we do some simplification, okay, like cancelling out those 2's and all, we'll be left with this. Okay.
Yes, sir.
Okay, now we'll be left with this. Now we have got g minus if, this is one complex number, g plus if, which is another complex number. Okay, if we call this some b, then this becomes b complement, right? That's what he's saying.
Yes.
Z dash
Okay, sir.
plus b complement into z plus b into z complement plus c. Understood?
Yes, sir.
Okay, just do it yourself once, this one, and see whether you got the same equation or not.
సార్ ఈ ఫోర్త్ వన్ వచ్చేసింది సార్.
వచ్చేసిందమ్మా?
ఎస్ సార్.
సెవెన్ డన్నా?
సార్ లాస్ట్ స్టెప్ సార్.
ఓకే ఓకే.
Done, sir.
Okay, very good. So what is saying here? Z square plus Z complement whole square equals to 2. This is a hyperbola. That's what is saying. We'll assume Z equals to x plus iy and Z complement is x minus iy. We'll substitute this and simplify, and we are getting this equation x square minus y square equals to 1, which is the regular equation of hyperbola. So you guys did not do hyperbola. That's why you might not know this equation. But now, for now, believe it that x square minus y square equals to 1 is the equation of a hyperbola. X square plus y square equals to 1 is the equation of circle, right?
Yes, sir.
Similarly, x square minus y square equals to 1 is the equation of hyperbola, which you will anyway learn later. Okay, ma? Okay, so these things you can do. Now you can convert rectangle form to modulus amplitude form, right? R and theta. This one you can simplify and then convert to r theta form, right?
ఎస్ సార్, ఈజీగా.
Okay, and argument z plus argument z complement, right? Okay,
Yes.
so this should be equal to 0, right? If z is x plus iy, z complement is x minus iy, this is theta, this is minus theta, so that should become 0, right? This one you can do, right? Magnitude you multiply, angles you add. What is this angle? Minus 1. Minus 1 is 180 degrees, and this one is minus I is how much? Minus 90 degrees, right? 180 degrees and minus 90 degrees. You just add these two angles because you are multiplying. So this becomes 90. Similarly, this one also. Angles you subtract, right? Agree, ma? You simplify this, and this you know how to express in r and r theta format, right? Here
Yes,
x
sir.
plus iy equals to cos theta plus I sin theta into cos theta plus cos alpha plus I sin alpha into cos beta plus I sin beta. You will multiply this and convert to a single one, right? And then you figure out what is x square plus y square. Agree, Amma? I think these all things you can do. Okay? Please try to finish this exercise. I mean, you can, this is just plain simplification, right? Please try to finish this exercise. And if you get any doubts, check in, mostly you should get in internet also, or otherwise we will discuss tomorrow. Okay, ma?
Okay, sir.
Okay. Now, we understood what is geometric representation, what is polar representation, etc. Okay? We basically know what exactly is polar representation, right? And earlier we discussed that complex numbers addition is like addition of vectors, right? You remember that, no?
Yes, sir.
Okay, and okay, so what he's talking about geometry is when you are multiplying two complex numbers, actually what is it, what does happen? I mean, the angles will get added and the magnitudes will get multiplied. That's what he's saying, right? R1, R2 is the multiplication of the this thing, magnitudes, and theta 1 plus theta 2 is the addition of angles. Okay, this we discussed already, right now? Okay. Now, a plus ib. If this point is z is a plus ib, obviously a minus ib is this point. So both are mirror images. That's what he's saying. Agree?
Yes, sir.
Okay. When we say mod of z1 minus z2, what does that mean? This means if z1 is x1 plus iy1 and z2 is x2 plus iy2, mod of z1 minus z2 equals to mod of this complex number, which is nothing but root of this thing, which is nothing but the distance between z1 and z2. Agree? Agree, Amma? When we are saying z1 minus z2 is actually this one, right? And when we say mod, it's actually this square plus this square, which is nothing but the distance between these 2 points. Agree?
Yes, sir.
Okay. So, and when we say, let's say this is z1, okay? And this is z2, like in vectors. Z1 minus Z2 means what? That is this vector, right? Z1 minus Z2, right, Nama? And when we say mod of Z1 minus Z2, that means mod of this vector. That means length of this one. Okay? That means length of this one is nothing but the distance between Z1 and Z2. That's what he is saying. Agree?
Yes, sir.
Okay. Now he's saying length, the distance between Z and Z1 is equal to distance between Z and Z2. Obviously, what does it mean? This Z should be the perpendicular bisector of Z1 and Z2, right? Mod of Z minus Z1 means distance between Z and Z1, right? So what does that mean? Z, the distance between Z and Z1 is equal to distance between Z and Z2. What does that mean? Z1 and Z2 are 2 points. This Z should actually be the perpendicular bisector of these 2 points, right? That's what he's saying, right? Z1 is this, Z2 is this, and the perpendicular bisector, that is actually Z. Okay, ma?
Okay, sir.
Okay. Now, there is some Z1, there is some Z2. Okay. The line connecting Z minus Z1, right? Z minus Z1, Z minus Z1 means what? That is this one, right? Z minus Z1 is this one, and Z minus Z2 is this one. Okay. Now, the angle between this one and this one is actually 0. That means both are in the same direction, right? Agree, understood? Z minus Z1 and Z minus Z2, they are in the same direction. This is what he is saying, right? Otherwise, the angle would be something else, right? If the angle is 0 as pi, that means they are in the same straight line. Agree, Emma? With Z common, that means all three are on the same straight line. Agree?
Yes, sir.
Okay. Z minus Z1. Okay. So Z minus, there is Z1, there is Z. Z minus Z1 is the line connecting this one, this vector, right? And similarly, Z minus Z2. That must be some other vector, either this or this, whatever. And now these two angles should be equals to 0 or pi. What does that mean? All 3 points should be on the same straight line. Okay. Now, this one, Z minus Z naught. That means the distance between Z and Z naught is constant, which is equal to R. What does that mean? Z naught is the center of the circle whose radius is R. And what is Z? The set of all of these points. Okay, on the circle. Agree? So in complex notation, we can say Z minus mod of Z minus Z naught equals to R. What does that mean? The center is this point and the radius is R. And this is actually the equation of a circle. Agree?
Yes, sir.
Okay. Now, listen to this carefully. The angle between Z minus Z1 and Z minus Z2 is actually pi by 2 or minus pi by 2. Okay. So there is some Z. Z minus Z1 is a line connecting or vector which is connecting Z1 and Z, right? That is this one. And Z minus Z2 is actually again the line connecting Z and Z2, right? That is this. Now between these two, the angle is saying either pi by 2 or minus pi by 2. Understood? This point you understood, ma? There are two lines. Okay. Z1 and Z2 are fixed, right? Z1 and Z2 are fixed. You want some Z such that the angle between this and this is 90 degrees, right? And that means Z should become the set of all of these points, right? Agree, ma? And what are all of these points? These points are the locus of this semicircle, right? Plane geometry, you know, right? Angle in a semicircle is 90 degrees. Any point on the
Yes, sir.
semicircle, if you are connecting the end points, the angle should be 90 degrees, right? So what is this Z? This Z is actually the set of all of these points, right? Any point, Z minus Z1 is this line, Z minus Z2 is this line, and the angle between them should be 90 degrees. Understood?
సార్ నేను ఒక 10 minutes లో కాల్ జాయిన్ అయ్యాను.
Okay, okay. Sound clear, ma?
Clear, sir.
Okay. Or otherwise, he's saying in another way, Z mod of Z minus Z1. What does that mean? That is the distance of this one, right? And mod of Z minus Z2. That is the distance of this one. This square plus this square is actually equal to mod of Z1 minus Z2, which is equal to this distance square. So, obviously, by Pythagoras theorem, he's saying this is again a right angle triangle. Right, again, this is a semicircle. Understood?
Yes, sir.
Okay. Now, uh, here, mod of z minus z1 and mod of z minus z2. That means this length by this length equals to constant. Okay. There is some
Yes,
z1,
sir.
there is some z1, there is some z2. Okay. This length z minus z1. Let's say if k equals to 1, what does that mean? This point, this distance and this distance is equal. So that then z is actually this straight line, right?
Yes, sir.
Okay. Now, if k is not equal to 1, let's say k is some 2 or something. What does that mean? You know Apollonius circle, right?
Sir.
This circle. In plane geometry in high school, you would have learned this. Apollonius circle.
No,
Okay.
sir.
Okay. So, what this circle is? Okay. For now, just to believe this. Okay. So, if there are 2 points, okay.
Yes, sir.
Okay, what is the circle is there are 2 points. Okay, then the set of all points, I mean the locus of points, which distance, whose distance from z1 to z2 maintains a certain ratio. For example, let's say this is in the ratio of 3 is to 2. Okay, from
Okay,
here
sir.
to here, this is 3, here to here, it is 2. Okay, so this one will also be 3 is to 2. This also will be 3 is to 2, like this. Any point, this also will be 3 is to 2. Okay. So this point is internal division and this point is external division. Okay. From here to here is 3. Here to here is 2. Okay. There will always be 2 points, right?
Yes, sir.
3 is to 2 internal division is this point. 3 is to 2 external division is this point, right? So these are the endpoints of the diameter and this exactly is the circle. Okay. We can prove this. We'll prove this when we have little bit more free time. Okay. So basically when there are 2 points, okay. This is plane geometry. When there are 2 points, okay, and the set of points which divide the set of points whose distance from these 2 points, okay, is in the ratio, is in some fixed ratio. That ratio should not be equal to 1. Okay. It could be 3 is to 2, it could be 1 is to 5, whatever. Okay. It
Yes, sir.
cannot be 1 is to 1. Then what are those points? Those points are actually the circles. 2 points very clear, right? One is internal point, one is external point. This is the diameter of the circle. Okay.
Okay, sir.
Understood now? So that's what he is saying. When k equals to 1, k equals to 1, obviously it is the perpendicular bisector. When k is not equals to 1, that is this circle. Okay. This circle, this distance by this distance is some ratio. Let's say some 2. Similarly, this distance, where is it? This point from here to here by here to here. That is also 2. If this is 2. Understood?
Yes, sir.
Agreed. Now, hyperbola, okay, there is ellipse. Ellipse is actually this distance plus this distance is always constant. By definition, that is the definition of ellipse. Ellipse is there are two foci. Okay, the distance of the point to the foci, okay, to the both foci, the sum of these distance is always constant. Okay, if the point is here, this distance will get reduced and this is increased. This one, this is reduced, this is increased like this. Okay, this is the set of all points whose sum of distances from these 2 points is actually constant. Okay, so what does that mean? Mod of z minus z1 plus mod of z minus z2 is actually constant. Okay, and what is this one? This one is actually the distance between these 2 points. Okay, ma?
Okay, sir.
Okay. Similarly, hyperbola by definition, the distance of this point from this one minus the distance of this point from this one, that is always constant. Okay.
Yes, sir.
Okay. So the set of points are these points and these points. Okay.
Yes, sir.
Agree, ma? Okay. Now see, the points in the organ diagram represented by complex numbers, these are collinear. You can easily do, right? This is plain straight lines problem. These 3 points are collinear. The slopes are equal, right?
Yes, sir.
Agree, ma? Similarly, equation of straight line downing these 2 points, you can easily do. Plain straight lines problem. Okay. X plus iy, locus of z mod z equals to 2. What does that mean? Mod z equals to 2. What does that mean? What is this locus?
Sir, it's given that mod z is 2, sir.
Uh, uh.
So,
Mod
అంటే
z means distance from center origin to basically mod z it means 2 equals to 2 means what? The set of all points whose distance from origin equals to 2. That's it, no?
yes, sir.
Set of all points whose distance from origin equals to 2. So that means that should be a circle with radius 2. Right now?
Okay, sir.
Okay. Point represents a complex number z in the origin plane. Amplitude is pi by 4. What does this mean? Angle is pi by 4. We don't know what is the length, right? What
Yes,
should be this one? Angle is pi by 4. The length we don't know. So what all points? This point, this point, this point, all of these are pi by 4 only, right?
yes, sir.
All of this, all of this. Basically, this line. Understood? And this line, we cannot take these points because once you cross this one, this angle is not pi by 4. This angle is this one. Understood?
Yes, sir.
Okay, so what is saying? Xy belongs to R square, x greater than or equal to 0, y greater than or equal to 0, and x equals to y. Understood? Why he is not taking this ray, this part? He is taking only this part. Understood now?
Yes, sir.
Okay. Now, okay, try this. There is some regular z, and z minus I by z minus 1 is purely imaginary. That means real should be 0. Substitute x plus I by in this, simplify this, and find out what exactly is the locus. Understood now?
Okay, sir. Yes, sir. Sir, x square plus y square minus x minus y equal to 0, sir.
Minus x minus y should be equal to 0. Okay.
Yes,
Agree
sir.
now?
Yes, sir.
Okay. And now xy should not be equal to y because the denominator will become 0. Right?
Yes, sir.
Here what is saying? Mod of this thing. That means the distance of z from this point. Okay. What is this point? Minus 1 and I. Right? Okay. This one we can write it as z minus 1 minus I. Right? Agree, Amma? This should be equal to 1. What does that mean? This is a circle with center 1 comma minus I. 1 comma minus 1. That is this one. Right? Of unit radius. Right? Agree?
Yes, sir.
Agree, Amma? Now,
Yes, sir.
what does this mean? Z minus I. The distance of z from minus I is less than or equal to 3. Okay? The distance of z from minus I. Okay? This is another
Sir,
circle like this.
second
This
step ఇంకోసారి explain చేయండి, sir.
Okay, so z minus z plus I less than or equal to 3. What does that mean? Z minus minus I modulus of this is less than or equal to 3. That means this is again a circle, minus I is the center. This time less than or equal to 3. That means this time it's a disk. Earlier, it was just the circumference of the circle. Understood?
Yes, sir.
Earlier, it is set of all of these points only. This time, it is set of all of these inside points also. Understood?
Yes, sir.
Agree?
Agreed.
Okay, this is a circle with center this one, and this is closed circular disk with center this one and radius this one. Understood now?
Understood, sir.
This part is clear? Okay. Equation of perpendicular bisector, you know, midpoint, that line you can do, right?
Yes,
Equation
sir.
of straight line, you know, and determining geometrically. Distance of z and 2 plus 3 equals to 5. Circle, center, radius, right?
Yes, sir.
Okay. And this one, z minus 1, this one, argument of z minus 1 and z minus 2. This is equal to 5 by 4. Okay. We can take z as some x plus I y and substitute and figure out what exactly is this. Okay, ma?
Okay, sir.
Okay, argument, these are vertices of equilateral angle. Very easy, right? Distances should be same. Okay. Equation of ellipse. Okay, z you take as x plus I y, and then I think you can simplify this. Okay, ma?
Okay, sir.
Okay, vertices of square. Very easy, right? I think this one we had done, right? This one is a real number. That means this one is this and this, they follow the same direction, right? The angle between
Yes,
them
sir.
is actually 0, right? This is equals to 3. Let's say real number means equals to 3. So that means z minus z3 minus z1 equals to some 3 into z2 minus z1. That means both are in the same direction. That means both are all three are collinear, right?
Yes, sir.
Vertices of a rhombus you can do, right? All sides equal and diagonals make 90 degrees, something like this. Okay, ma?
Okay, sir.
Okay, all sides equals and z1, z2 are collinear. If this exists, this thing. Okay, try this. Okay, and I think, okay, these are little interesting problems. Just try this. Okay, ma?
Okay, sir.
These problems I think you might face little. Okay, these are straightforward only. These 4, 5, 6 I think are little interesting. Just try them. Okay.
Okay, sir.
Okay. So then I think you should be able to finish off this one. Okay. This
Yes, sir.
complex numbers, this chapter you should be able to finish. Okay. Then we'll have another small chapter which is called De Moivre's theorem, which is again straightforward. Okay. One, and please try to finish it by these 4 exercises. Tomorrow we will not have class. Try to finish it off by day after tomorrow. Okay.
Yes, sir.
Okay. And so far what De Moivre's theorem is not discussed now in college yet.
No, sir.
This is not discussed. I think this much is discussed now. Geometric representation is not discussed, I think, right?
Yes, sir.
Okay, okay, cool. But anyway, try to finish this. Once this is done and DMOS level is done, we will have lot of background and we can get into easily doing this one, PYQs. Okay?
Okay, sir.
Okay, and did they give any this thing, what you call timetable? Not
No,
yet,
sir.
no? Not yet. Okay, cool, cool.